as promised, we're going to rip this baby open. So it looks like the way that they put this together is that they have these plastic pins probably that stick out of this case, that stick through these holes in the backside of this metal plate, and then they just melt the pins over. So, pretty sure if I use the right size drill bit and drill out those plastic pins, I should be able to pop this cover off. We'll find out. Now I've drilled off the ends of those plastic pins. Let's start doing a little bit of prying along this edge here and see if we can't pop this off. Well, as I suspected, heavily potted. Potted just means where they take the electronic circuit and they have it inside of a case, and then they fill the case with a chemical that, when it hardens, basically completely encases all the electronics. There's a couple of reasons why they might do this. One reason is to isolate it from any moisture, which this is a high moisture environment in a marine environment, and they want to make sure corrosion doesn't occur to any of the connections. Another reason is for mechanical vibration, because you don't want a soldered connection to loosen over time through repeated mechanical vibration. And then sometimes they do it just, not in this case, but like I've seen some electronics where they potted them or did things just to hide what the circuit was because it was proprietary. In this case here, it's just for the mechanical vibration isolation and the moisture isolation. But anyways, you can kind of see the way that is. It's actually kind of soft and pliable. It makes me wonder whether or not I could go at it with an X-Acto knife. I can see a capacitor right here. You can actually see the rating on it. It's a 470 microfarad 50 volt cap. So that might be your capacitor for discharge right there. It could also be just a filter. Although over here there's another capacitor. This is a 1 microfarad 500 volt DC. That's probably your discharge one there. Yeah, that's right, because this voltage is too low on this one. So anyways, here's a transformer. But yeah, I'm kind of interested to see what's underneath there. Sliced off a little corner of the stuff right here, and now what I'm going to do is I'm going to see whether or not this has a melting point. Well, the first test proved inconclusive. The stuff does melt, but it seems to have a pretty high temp melting point, and it got too smoky down here to continue to try and burn the little piece I had in a little metal container. So I went back to chiseling this off here and actually exposed the Phillips head screw on this corner, and then I dig down a little bit further. You can see this little tiny triangle right here. That's the edge of the PC board. So it looks like this PC board is screwed down to this backing plate, and there's probably some standoffs underneath there. But it'd be nice if I could get those screws exposed and removed. And then maybe I could take this plate off and see the back of the PC board better. I don't know. Of course, that might not make any sense to bother doing if I can't even get this stuff off of here. So I think I'm going to do a little bit of research and see whether or not I can come up with a plan. I figure there's going to be, if it's possible, if you can do it, there's probably only one of two ways to do it. There's either a chemical solvent that will dissolve it. The key is to find the solvent that will dissolve this, but not harm the components. Or it's a matter of heating it to the right temperature, high enough to melt this away without damaging the components. Well, did a little research last night on the internet on how to remove electronics from potted situations like this. Said really there's several different types of potting material, maybe even more than that, I mean, but several different categories, I guess, of potting material. The hardest to remove is an epoxy. This does not appear to be an epoxy because it actually feels like it's a little bit pliable. This might be a silicone-based product, which, if it is, one of the suggested ways to deal with this is to heat this up, and as it heats up, it gets easier to dig this stuff out. The other way is chemically. The problem is you've got to find something that will act as a solvent to this particular material. So what you're going to do is you're going to find something that will dissolve this stuff. There were several different chemicals that were named as possibilities. The problem is a lot of the guys admitted that there's a possibility that you're going to damage the components while you're doing that. So, I mean, some of these components, if they get damaged, I don't really care because I'm going to just want to replace them if I can. However, I wouldn't want to hurt like the enamel on these windings, or say destroy the numbers off of some of the semiconductors, making it impossible for me to see what numbers are on them. So anyways, what I'm going to do is I'm going to use my little shop oven here. This is just an old toaster oven we were going to throw out. I use it to dry parts, and when I need to heat something up, small items, it comes in handy. So I'm going to fire it up to 200 degrees and throw it in there. And the components should be rated to easily take that temperature. Well, after heating it up, it doesn't really feel that much softer, but then when you go to cut into it, it definitely does come off easier. Still a real pain to chisel this out, and you got to be real careful. This is a inductor right here that I could easily have sliced right through, but I had seen it, so you kind of want to shave off a little at a time until you're sure there's nothing there, and then you can go right down to the, see, I'm already down to the PC board there. I was able to clean up this screw enough to remove the screw. Let's see if I can find the screw on this side. I turned it over, and I can now see that since I removed that screw, I got a hole here, and then if I look really carefully, there's the other screw. So there's only, that's just a mark. There's only one other screw, and that is buried right in this area. So if I can get down into there, get that screw out, I might be able to actually separate the board from this metal piece. Well, there's my other screw. Right next to it here, I've got a small transistor. It's my first semiconductor that I've uncovered in this mess. You can actually even see the number on it. I scraped it off. It's a 2N3414. If memory serves me, that would make it that makes it a NPN transistor? I don't remember. But anyways, see if I can get that screw out. Got that screw loose, was able to pry this away from this big metal piece. This metal piece is the heatsink. So here's my first big semiconductors. That's heatsink compound. That's a special paste that helps conduct the heat away from the body of the semiconductors to this metal case. This is a mica insulator. Well, cleaned up the bottom of the board. Here's the two big semiconductors. This one right here, it's got, I think, what they call a TO220 style case. That makes it look to me like it might be an SCR, and that's down the end where the capacitor is, so I bet you that's the SCR to discharge the capacitor when it's triggered. And then this one over here is a bigger one. Actually, that's a TO220 case too. I just didn't take the silica insulator off of that one yet. If I take the insulator off, you can see that that one is also a 220 case, but that might be a transistor. Let's see if we can see a number on that one. Well, that one that I figured was an SCR, looks like it just says S616 on it. MEX, Mexico. And this one that I would have thought was a power transistor in Darlington or something like that is marked I-H EDT. It's Echo Delta Tango 63A and then a 9135 on the bottom. Let's see if I can run those numbers and see what they might be crossing to. This semiconductor right here is the mystery. It's got an S616 on it, an MEX on it, and then some sort of logo or symbol on it, silk screened on it. And that's pretty much all I was able to come up with on this. I tried a number of different databases and couldn't find anything that made sense as far as what this was. This one, I don't remember what the number is on it, but this one actually ended up being I believe a Darlington power transistor. which is still readily available, which is nice. So that kind of tells me a couple things. Oh, also I ended up breaking the leads on this one when I bent it up to try and get a better look at it. But anyways, so that went here. And if I were a betting man, I'm looking at the way this is put together. Looking over here, you got this big capacitor right here. Okay, 500 volt DC capacitor, and that's in the proximity of this side of the board where this semiconductor that I can't identify is. So I'm willing to bet that's the SCR. I'm willing to bet that's a silicon controlled rectifier, and that gets triggered and that dumps this this charge from this capacitor. And then over here on this side is your primary circuit, I think, that's actually working as like a switch mode power supply or some sort of a oscillator circuit with that Darlington power transistor that's still mounted there, because that's on this side here where this electrolytic capacitor is, which is lower voltage. I think that works to take the 12 volts that is coming in and generate the several hundred volts that this theoretically operates at. Somewhere around 500 volts, I guess, is what this is supposed to kick out to that primary winding on that coil. So this small transistor right here may very well be a driver transistor for that circuit, or it may have some other purpose. It may be some sort of a clamp circuit for protection. Not really sure. Don't know if there's any other semiconductors underneath here. I wouldn't be surprised if the only other thing underneath here is maybe some diodes and resistors and some other passive components. So this little tiny transistor here, I think it also had a part number that I didn't actually research, but looked good. Yeah, this is a 2N, looks like a 3114 maybe. That transistor sounds like a really good part number. So for giggles, I got my DVM out. I'm going to put it on the diode range for testing diodes, and I'm going to just do some checks to see if I can't figure out what this is. Well, right off the bat, I found something I didn't expect. Typically, this style case, I believe, is a TO220 case, and that just means that the outline of the case. Typically, when you have a semiconductor with a TO220 case like this, typically this metal tab up here that a screw can go through to screw it down to a heatsink, typically that will be common with the center pin on the three legs of the device. In this case, I'm getting infinite resistance between the center pin and here, and between the other two pins also. It's almost as if this tab is completely isolated from all three pins. Also, from the two outer pins, in one polarity, I'm getting a reading of 0.049, and then when I switch polarity, I'm getting the same reading of 0.049, which is not a dead short. It's dropping some voltage, but it's dropping it in both directions, which is kind of strange. And then from either one of the outer legs to the middle leg, no matter which polarity I observe, I'm getting no reading whatsoever, which tends to indicate to me that this is a bad semiconductor. But since I don't know exactly what this semiconductor is, it's kind of hard to make that call. But it's kind of unusual to have no reading between two legs of a device like this.